we're going to sketch this power 4 function, and we're going to need polynomial long division in order to figure out the x-intercepts in order to do that. And if you can sketch a power 4 this way, then you can sketch a cubic. It'll just be one step fewer. If you can do this, you can do it to a power 5 or a power 6 or a power 7, whatever it is, as long as you can find enough x-intercepts to make it work. So first thing we're going to do for our sketch is get the y-intercept. So y-intercepts happen when the function has zeros filled in for all the x's. So if I put a 0 here, this piece will be gone. So will this piece. So will this piece. So will this piece. And only this will remain. So this function has a y-intercept of 24. Now x-intercepts happen when this function equals 0. So the trouble with these is I'm going to have to start guessing to see if I can find a number that works. So if I were to try 1 to the power 4 is 1. 1 cubed is 1. 1 squared is 1. 1 is just 1. So this would end up being worth 1. 1 plus 2 would be 3. 3 minus 13 would be minus 10. Minus 10 minus 14 is minus 24. Plus 24 is 0. So this is true. True for x equals 1. Therefore, x minus 1 is a factor of f of x. So I'm going to divide that factor out using polynomial long division. So shake my marker, get some ink. If I set this thing up then, I'm trying to divide x to the power 4 plus 2x cubed minus 13x squared minus 14x plus 24 by this factor I just identified of x minus 1. All right, so what times x gives me x to the 4? It has to be an x cubed. X cubed times x is x to the 4, and x cubed times minus 1 is minus 1x cubed. This minus this is gone. 2 minus negative 1 would be 3x cubes. This I haven't dealt with. This I haven't dealt with. This I haven't dealt with. Rinse and repeat. What times x gives me 3x cubed? Well, that would have to be a 3x squared. 3x squared times x is 3x cubed. 3x squared times minus 1 is minus 3x squared. These are gone. Minus 13 minus negative 3 would be negative 10x squared. And then this I haven't dealt with, and this I haven't dealt with. What would I multiply x by to get negative 10x squared? Well, it has to be a negative 10x. This times this is minus 10x squared. This times this is plus 10x. This minus this is gone. Minus 14 minus 10 is minus 24x's. Ooh, that's good. Because what times x gives me negative 24x? Well, minus 24 does. This times this is this. And minus 24 times minus 1 is plus 24. And unlike the examples in the other section, this one divides evenly. Actually, that happened when you were factoring the cubics too, didn't it? So I've got this factoring out evenly, which is good. That confirms this is a factor. So what I figured out then is I've got one x-intercept at x equals 1, which I guessed. And now I have a reduced polynomial that I can dig through to try and find a new factor. So I'm just going to erase all of this. So I have to go hunting for another x-intercept, but because I've already pulled this factor out, I don't need to go hunting in the full power 4 function. I only need to root around in what's left. So if I tried 1 again, 1 plus 3 would be 4. 4 minus 10 is minus 6. Minus 6 minus 24 is minus 30. That's not going to work. So I'm going to try 2. So 2 cubed would be 8. Let's see, 8. 2 squared is 4, times 3 would be 12. 2 times negative 10 is negative 20, minus 24. That's minus 44 and only 20, so 2 doesn't work. So I'm going to try 3. 3 cubed is 27. 3 squared is 9. 9 times 3 is 27. 3 times negative 10 would be minus 30 and minus 24. 27 and 27 is 54. Minus 30 and minus 24 is minus 54. So that equals 0. So this was true. This thing equaled 0 for x equals 3. Therefore, x minus 3 is a factor. So I'm going to divide this new factor out of the existing cubic. Find some space over here to do that. So x cubed plus 3x squared minus 10x minus 24 divided by x minus 3. So what times x is x cubed? Well, that's x squared. Minus 3 times that is minus 3x squared. 3 of them minus negative 3 of them is 6 of them. And I haven't dealt with this. What times x is 6x squared? Well, that's 6x. 6x times x is 6x squared. 6x times minus 3 would be minus 18x's. These are gone. Minus 10 minus minus 18 is 8 of them. Oh, that's good too. What times x is 8x? Well, that's just 8. 8 times x is 8x. 8 times minus 3 is minus 24, which divides evenly. That's encouraging. So this is all that's left. Okay, so I could, let's see, at x equals 1, x equals 3. Now I could keep guessing. I could keep trying to figure out what works in there. But if you look, if I get rid of all this division stuff, that's just a quadratic. So I might be able to factor that just with simple factoring. Or if I'm not sure about how to factor it, I could plunk it into quadratic formula and calculate the next two x-intercepts. This one happens to factor as two numbers that multiply to 8 and add to 6 would be x plus 2, x plus 4. Therefore, there's an x-intercept when this equals 0, so x is negative 2, or when this equals 0. So x equals negative 4. All right, so I'm going to erase this and get myself a grid. All right, so I'm just going to start dropping dots on. You'll notice my scale, I left 2 squares for 1 unit on the x, and I jumped by 2's on the y just so this would fit. I have a y-intercept at 24, so that's here. Put a dot there. And I have an x-intercept at 1, and I have an x-intercept at 3, and an x-intercept at negative 2, and an x-intercept at negative 4. All right, now, if you look at these 3 dots, the only way to connect these 3 dots without crossing the y-axis or the x-axis in any place that's forbidden is to connect them like this. Somehow. Notice I am being a little careless about how I draw that line. It's because I don't actually know where it goes. I just know it passes through this place, and this place. But on this side, I have to sweep under the axis and somehow get back to here before taking off to wherever. Because I'm not allowed to cross over the x-axis again. I don't have any more x-intercepts. On this side, I have to swoop underneath, get back up to the x-axis by -4. And then I have to take off on this side. So I end up with this funny looking thing like that. And x to the 4s look like w's, so you should expect that. So really all I did here was I got the y-intercept. That's easy. You just put in zeros everywhere for the x's, plot it on your graph. Then you have to hunt and pick at least 2 x-intercepts. So when you go to do these in the practice questions, there are at least 2 solutions that work. And to save all of us some stress, those numbers are probably within plus or minus 5. So you keep trying numbers until you get one. As soon as you get a hit, you divide out that factor and acknowledge that x-intercept. When you get another hit, you factor it out, no, divide it out rather, acknowledge that x-intercept. Then you can use quadratic formula or factoring to get the other 2, plot them in, and just close your eyes and connect the dots. And as long as it looks roughly like a W, then you're good to go. So power 4s look like that. You know, it says 1, 2, 3 little bumps in it. Cubics are this sort of thing. Right? They can have 1, 2, 3, up to 3 x-intercepts and 1, 2 turnaround points. Parabolas look like that. They can have up to 2 intercepts, and they have only 1 turning point. You notice that the turning points, because this comes from an x squared, this comes from an x cubed, this is x for 4. Do you notice that the number of x-intercepts that are possible matches this number? And the number of turnarounds it's allowed to have is 1 less than that number. So an x to the 5, that should have 5 possible x-intercepts. So it could cross 2, 3, 4, 5 times. And it should have 4 turnarounds. So 1, 2, 3, 4. Something like that. So you can use this patterning to get the rough idea in the first place. But basically, it's just get a y-intercept, hunt for x-intercepts, use polynomial long division to find any ones that you can't, and then plot the dots and take a guess.